Hello everyone. In today's lesson, we're going to start looking at the second part of the trigonometry unit, which deals with the periodic nature of trigonometric functions. So first of all, what does the word periodic mean? The word periodic means something that has a repeating pattern, such as the phases of the moon, the tides, you getting up in the morning, brushing your teeth, eating breakfast, going about your day, the next day when you wake up, starting over, doing the exact same thing. Those are all examples of periodic scenarios. Now, in order to be able to be all on the same page, we need to know a certain amount of terminology regarding periodic functions so that we all know what we're talking about when we discuss them. In math, we are very interested in the graphing of periodic functions, and therefore, what is the terminology related to their graphs? Or tables of values, which is another way of representing this data. So, the first two words I'd like to concentrate on are cycle and the period of this graph. Now, cycle and period are two words that are actually very closely related because they are measured in a very, very similar way on the graph. So let me explain. If we start at the starting point of this graph, where along the x-axis does the graph start repeating the pattern again? Now, what you're looking for is another point that is in the exact same state as the point that was just highlighted. So that point would be right here. Now, why is it this point and not mistakenly done by many students, this point here? Well, these 2 points are at the same height, but they're not in the same state. This point, the purple one, the graph goes downwards after that point. But from the original point, the graph goes upwards from that point. So it's not good enough that the 2 points be at the same height. They also have to be at the same state. That word, state, in trigonometry is called the phase of the graph. These 2 points are in the same phase because the graph is going upwards from the same height from those 2 points. The distance between 2 points that are in the same phase is called the cycle. Now, the cycle doesn't technically have a number associated to it. It's more related to the picture. If I asked you to draw 2 cycles of this graph, you would do this pattern and then repeat it all the way up to this point, which would be where the second cycle ends. So you'll notice that this graph is 2 cycles and a bit. Okay? The word period has to do with the number along the x-axis that represents how far have we gone for one cycle. So the period in this case would be from -1 to 3 is a distance of 4, which you could calculate by doing 3 minus -1 if you really wanted to use some math if the numbers weren't pretty, which would also give you 4. So in a sentence, I could say, draw 3 cycles of a graph that has a period of 7. The word cycle means how many pictures you're going to draw. The period tells you how long it takes on the x-axis before one of the pictures repeats itself. So it's a very similar thing, but they are 2 different words, okay? And they represent 2 different things. So once again, the phase means 2 points that are in the exact same state on the graph. And by the way, you can calculate the period from multiple different places on the graph. If we did start at 0, 0, what would be the point that's in the same phase later on the x-axis? Well, we would go all the way to this point here because it's at the same height and it's in the same state. The graph is going downwards through that point. Therefore, that would also be the period length. And you'll notice from 0 to 4, it's much easier to calculate, right? The distance is 4. You could even go to points that aren't as nice to see. For instance, you could go here and find the next point that's in the same phase, which would be here. But you wouldn't probably do that because you can't clearly see what the x values are beneath that point. But you could. All right? So we've talked about the first three words. The last one on the list is the amplitude. For the amplitude, it is half the distance from the height to the lowest, the highest y value to the lowest y value on the graph. So now we're going to be talking about the distance vertically of this graph. All right. So I'm just going to adjust one little thing here because it isn't quite to scale. If this is 1, let's change this value here. It would be more likely to be, let's say, -2. Okay. So just to have it a little bit more to scale. So half of the distance from the highest to the lowest y value. So let's first of all find half of the distance. How do you find half of the distance between 2 points? Well, in grade 10, you saw the midpoint formula for a line segment. Now, we're not technically doing a line segment here because there's only y values that are being considered. So we're going to find just the y portion of the midpoint, which is the equation y1 plus y2 divided by 2. So y1, it doesn't matter which ones we choose as y, so I'm going to use 1 plus y2, which is -2, divided by 2. That gives -1/2, which is -0.5, right? -1/2. So if -1 was here, my midpoint is right here. Now, when you find the midpoint of a periodic function, sometimes we'll be drawing a dotted line through that point. And that dotted line is a special type of axis, which I like to call the axis of equilibrium, which is more of a physics concept than a math concept. And I'll get to that more later on. So that's not a term that we're going to talk about too much today, but you could just call it the axis if you want. All right. The distance between that axis and the highest point on the graph is your amplitude. So how do I calculate that distance? Well, you could count it, right? If this is at -0.5, the amplitude is 1.5. You could also use math to do that. Now, the distance between 2 points is a subtraction, so you could do 1 minus -0.5. And this would be if the numbers weren't pretty, but I'm just showing you the math here, which would be 1 plus 0.5, which would be 1.5 again. All right? Now, they actually say that the distance, the amplitude can be calculated downwards as well, but the amplitude is an absolute value. All right? So even though it would be -1.5 from the middle to the lowest point, the amplitude is an absolute value, therefore it would be positive 1.5 again. To give you a real world scenario where the amplitude is used, the amplitude is the same word that you use when you plug a guitar into your speaker, which we call an amp, right? So basically the amplitude is going to be how loud a sound is. And there is a relationship between periodic functions and sound. Let's look at a couple of examples now. So determine whether each function is periodic. If it is, state the period. So let's look at this first graph. If we were to find another point that was in the same state as this first point, you would probably point to this point here because both graphs are going downwards from that point. But the problem is they're not at the same height. And because they're not at the same height, even though it looks like this graph does have a repeating pattern, which it does, it is not considered periodic because those points do not repeat themselves at the same height. Okay? However, if we go over to this graph, is there a point later on the x-axis that is at the same height as this one and in the same phase as this one? And yes, there is right here. Because the graph goes down after the point, the graph goes down after the point. So this distance would be our period. And our period in this case would be If you look at the scale, it's going up by 2, so 2, 4, 6, 8. So the period is equal to 8. Now, if you wanted to make your life a little bit easier, you could start here to measure the period. Find another point in the same state or the same phase, which would be this point here. And now because we went from 0 to 8, it's much easier to see that the period is still 8. What about this example here? The graph has a period of 7. Find the value f of 6 and f of 20. So now all of a sudden we're mixing in our function notation with our trigonometric graphs, all right? Or sorry, not trigonometric graphs yet, our periodic graphs. F of 6, just a reminder, means what? It means find the y value when the x value equals 6. So when the x value equals 6, which would be right here, the y value equals -1. Therefore, f of 6 is equal to -1. Now, how would I go about finding b, which is f of 20? So the first thing I want you to notice is the graph doesn't go all the way up to 20. The highest the graph goes to is to, sorry, not 14. It's going up by, oh yes, it's going up by 1. So 11, 12, 13, 14, yes. So it goes up to 14. It doesn't go all the way up to 20. So that means we have to extrapolate. We're going beyond the values on the graph. So we have to extrapolate the graph, right? But is there a way to figure this out without actually drawing the rest of the graph? Because it's kind of difficult here. I don't have the next squares drawn out here, so I'd have to do some finagling to try to get it to work. Is there a way of figuring it out? Well, we know they told us that the period is 7, which we could have just seen by looking at this point and this point, right? So how would we find the phase that x equals 20 is in that would be similar to one of the phases that we already have within the first 7 of our period? Well, what if we divide 20 by 7? 20 divided by 7 is 2 point something, right? Because 2 times 7 is 14. So if we do 2 times 7, we know that 20 is past 14. How much past 14 is it? Well, 20 minus 14 is 6. So 14, if you look, is in the same phase as the starting point. So by dividing by 20, we found out where the graph would repeat itself on its way to getting to 20. So I can come right back to the beginning here, and if I count 6 over, 1, 2, 3, 4, 5, 6, this point should be in the same phase as f of 20 is. Therefore, f of 20 should be -1. Let's look at one more thing. In your textbook, here is the math definition of a periodic function from your textbook. In general, a function f is periodic if there exists a positive number p such that f of x plus p is equal to f of x for every x in the domain of f. Wow, that is a lot of information. But can you make sense of it? What does f of x plus p mean? F of x plus p means go p further along the x-axis than your x starting position. Okay, so let's say our x starting position was 2. If I go a distance p from that point, all right, I'm going to be at 2 plus p along the x-axis. Sorry, 2 plus p along the x-axis, right? If f of x plus p equals f of x, now what does that mean? F of x plus p is a y value. So if the y value at 2, which is our f of x, equals the y value at f of 2 plus p, which is our f of x plus p, the two y values are the same height. And if that happens for every x in the domain of f, so if that continuously happens, every time you add p to your point, you have a periodic function. The smallest positive value of p is the period of the function. All right, so just to show you how they will define mathematically the definition of a periodic function in a sentence form in a math textbook. So sometimes you're going to read sentences like that. They're going to look extremely scary, but if you break it down a little bit at a time, you should be able to make sense of it. So we're going to finish the lesson there. There will be some homework that will be attached to this lesson. Please get that homework done as fast as possible and make sure you understand it. And if you have any questions, let me know.